Hello, my name is Urmisha Chatterjee and this is my second task as a data science and business analytics intern at the Sparks Foundation. My task is to predict the optimum number of clusters from the famous IDS dataset. Clearly, this is a problem of unsupervised learning as my task is to identify the similar observations and group them into clusters. To solve this problem, I am using the RStudio, but someone can use other environments like Jupyter Notebook or Spyder to solve the same problem. First, I have read the data into my environment. As you can see, it has 150 observations on 6 variables: ID, sepal length, sepal width, petal width, and species. For my clustering purpose, I'll be only using the continuous attributes, that is sepal length, sepal width, petal length, and petal width. So I have extracted the relevant columns and stored them in a separate data frame. So this is my new data frame with only those columns in which I'll be performing the clustering. So there are various clustering methods, of which I am using the k-means clustering because it is the simplest of them all. To say in a few words k-means clustering, first one have to identify the number of clusters in which he or she wants to group the data. Once the number of clusters is decided, a centroid for each of the cluster is assigned. Initially, since clustering is an iterative process, the centroids are randomly assigned, and for each of the observation, the distance of the observation from each of the centroids is calculated using some suitable distance measure like Euclidean distance or Manhattan distance. Then the observation is assigned to that cluster, the corresponding centroid of which lies closest to that observation. In this way, all the observations are assigned to clusters. So this is the first iteration of k-means clustering. In the next iteration, the centroids are recomputed, but this time not randomly, but using the observations that belong to that cluster. Then the observations are reassigned to the clusters and the centroids are then recomputed. So this process goes on and on until we observe that the centroids are becoming more or less stable. That is, over iteration, the newly computed value of centroids are not changing. So this is to say in a few words how k-means clustering works. So my first task is to identify the optimum number of clusters. Now since this is a 4-dimensional data, it is not possible for me to visually represent the data and identify the number of clusters. So instead, I will be using the famous elbow method to identify the number of clusters. According to the elbow method, the optimum number of clusters is the one for which the within sum of square is minimum. So I have calculated the within sum of squares for a possible values of number of clusters ranging from 1 to 15. So this is giving me an array with 15 values. These 15 values are the within sum of squares corresponding to the number of clusters. Next, I have plotted them in a line plot, the number of clusters and the corresponding within sum of squares. Let us have a zoom view. So as you can see, as the number of clusters is being increased, the within sum of square first decreases very rapidly, but after a point it is becoming more or less constant. So while selecting the optimum number of clusters, two things has to be kept in mind. First is that the within sum of square is minimum and the number of clusters is also as small as possible. So keeping these two things in mind, my optimum choice will be a cluster number of 3. So I will be performing k-means clustering with 3 clusters. The k-means command in RStudio helps to find the k-means clustering very easily. So let us have a look at the clustering vector. This is my clustering vector. It's an array of 150 observations. Each observation defines the observation to the original data, the cluster to which it belongs. That means the first one, it says that the first observation belongs to cluster 1. See, The 40th observation is also 1, indicating that the 40th observation belongs to cluster 1 and the 150th observation belongs to cluster 3. Now in a cluster plot, I have tried to visualize the clustering. Now since we have 4 dimensions, so I have just picked 2 dimensions from the data and tried to represent it in a cluster plot. Let us have a look at the cluster plot. Here it is. So as you can see, the 3 clusters has been shaded separately. The symbols has also been changed to identify the 3 distinct clusters. So the clusters, these 2 clusters are somewhat overlapping, but this cluster is absolutely distinct. So here I come to an end of my task of clustering the data, and I have visualized it using 2 of the dimensions. Someone can visualize it using some other dimensions as well, like petal length or petal width. Thank you for listening.